Okay, my friends. So what I've done here, we don't have the ability to play this game together like we did in class with the pass line bet. So instead of doing that, I figure I'll just have Excel play it for us. So it's gonna throw dice right here, and then it's gonna keep track of wins or losses. And that the wins or losses is a little bit convoluted. I'll explain that to you in a second. But I can just keep rolling dice in this spreadsheet by just re-randomizing. So right there. Well, you can see why this was a loss for the don't pass bet. That's a sum of 11, right? 6 and 5. That means the pass line bet won. If the pass line bet wins, that's why there's a loss there for the don't pass. Let's try again. All right, we just rolled a 7, which is the other way the pass line bet wins on the opening roll, which would again be a loss for the don't pass bet. Let's try again. All right, this is interesting, and we're going to come back to this one. This is the one roll that makes it different. A 12, a sum of 12 right there, double sixes, boxcars, would be a loss for the pass line bet. Now, usually a loss for the pass line is a win for the don't pass, but it's not. It's not. It's called a push. I don't know why it's called a push, but nothing happens. If a push, if double sixes are rolled on the opening roll, of a don't pass bet, the player's ante just stays in the pot, doesn't move, and it's like a do-over. Okay, let's play again. So this is a sum of 9. Now, this is where it gets interesting, because a 9, when we played in class, a 9 would not, you wouldn't be done after a roll of 9, correct? You'd have to then pick up your dice and roll again and again and again until one of two things happened. Either you roll a sum of 9 again, or you roll a sum of 7 again. And if the 7 comes before the 9, then the pass line loses. And if the pass line loses, that means that the don't pass bet wins, and vice versa. Now, what happened here? We lost. Now, where you have to see this happening is down here. This is kind of where I've got the guts and the brains of the spreadsheet actually doing its thing. So you can see right here, I've got die 1 and die 2, 5 and 4, and the sum is 9. Okay, it's the same thing as you see the dice up top. The spreadsheet knows it's not done rolling yet, so it's going to roll again. The next roll, it rolled a 5 and a 1 for a sum of 6. That's not a 9, nor is it a 7, so the spreadsheet just ignores it and keeps going. Next roll is a 2 and a 1 for a sum of 3. Again, that means nothing at this point in the game. We roll again. The next roll is a 4 and a 5 for a sum of 9. That means that if you did a pass line bet, you would have won because you matched your point. If you rolled a sum of 9, you rolled a sum of 9 again before you rolled a 7. That means the pass line won, which means up here, that is why the don't pass bet lost. All right, let's actually try to see the don't pass bet winning. Lost again with an opening roll of 11. Okay, here we won. All right, let's see why we won here. That's double 5s. That's a sum of 10. That means the roller then has to pick up the dice and roll again. Now look down here. There's the double 5s and the 10. Okay. Next roll, they pick up and they roll a 2 and a 5, which is a 7. Boom! That means that the pass line bet would have lost, which means the don't pass bet would have won. Let's do a couple more. Okay, there's an opening roll of 11. We're getting a lot of opening rolls of 11 in this simulator today. It's kind of fun, which again means that the don't pass better loses. Here we won. Okay, let's see why. We rolled a sum of 8. Okay, so down here to the guts. There's your 6 and your 2 and your sum of 8. Next roll was a sum of 6. Next roll was a sum of 6. Next roll was a sum of 11. Next roll was a sum of 7. That means the pass line better lost, which means the don't pass better won. Those are hard to say. It's hard to say. Okay. I think you get the gist. And you don't even have to understand how this game works because I'm going to let the game collect the probabilities for us. What I'm going to do right now is I'm going to hold down this F9 button for a good long time to start right now while I'm talking. We're going to let it play, and you can see every once in a while you see a push pop up, but usually there's some wins or losses, and I'm going to let this thing play a good long time. I'm going to speed it up once I'm done running my mouth over here and get at least a few thousand trials, and then we're going to come back with the distribution of values that are showing here, and leave the expected value on. All right, my friends, I think that's 36 some thousand trials. I'm pretty sure that's probably it's good enough. Now, while the game was going on and the randomizer was playing, I was collecting that data for you right here. So that is those are the probabilities. It looks like over those almost 40,000 trials, you had a 49.1% chance of losing, a 48.2% chance of winning, and the rest, 2.7%, was a push. That's those double sixes that happened. Okay, from that distribution right there, you're going to do the next few questions. Go get them.